Okay folks, so today we're looking at question 4 from the 2019 question in section B. So to start, we're going to read that question. So the elevation and plan of a sand bucket and a beach ball are shown. A 3D graphic of the bucket and the ball is also shown. The bucket and ball consist of a truncated inverted cone A and a sphere B respectively. The sphere rests on the horizontal plane and is in contact with the truncated cone. The bucket has a semicircle handle S positioned as shown in the plan and elevation. Draw the given elevation and plan showing all constructions and points of contact. Draw the development of the conical surface A. Draw the development of the semicircle handle S. Okay, so there's a lot of information there, so we're going to go through it now again. So the elevation and plan of the sand bucket are shown. Okay, so we have the elevation here on the top above the XY line, and we have the plan here below the XY line. A 3D graphic of the ball and bucket is also shown. So this is a 3D graphic. It just helps you visualize these two 2D shapes in 3 dimensions. The bucket and the ball consist of a truncated inverted cone. Okay, so 2 things now about that cone. So we all know what a cone looks like. So I'm just going to sketch a cone here. So we see the base of it and we see the side of it coming up here as well. Okay, so we have a cone like that. Okay, inverted means that it's going to be flipped upside down. So we're going to see the bottom of the cone now, like this. Okay, so we're going to see the cone inverted, so it's going to be flipped upside down. And truncated means that we're going to cut it, so we're going to slice it with a plane and we're going to cut a section off it. So we're going to see something like that on the bottom of it, and we won't see any of this section here. Okay, so just bear in mind that those 2 words are used with that cone. So it's truncated and inverted. And then the sphere is B, so we see the sphere here. The sphere rests on the horizontal plane. Okay, so that's good to know that that sphere is on that XY line. Okay, and is in contact with the truncated cone. So it's in contact there with the cone A. The bucket has a semicircle handle S. Okay, so as we look at it here, it looks like an ellipse, but we know that it's actually a semicircle as we're looking at it. Positioned as shown in the plan and elevation. Okay, so step A is to draw the given elevation and plan and show all constructions and points of contact. We'll be able to start that now in a second. Draw the development, so we'll be able to do that, and we'll be able to draw the development there in C as well. But just to help you visualize them shapes as well, I've drawn them out here on Onshape. Okay, so as we're looking at that truncated cone and sphere, we can we can't actually see the point of contact, right? So to see the point of contact between them, we have to look in at it like this. So we're looking in at the points of contact. And we also see here that the bucket handle is actually a semicircle, as they say. So that handle S is a semicircle. As we look at it, normal to the front plane, okay, that looks like an ellipse. But we know that when we look at it normal to this 45-degree line plane, that's actually a semicircle. Okay, so the first thing we need to do is pretend to look at the sphere like that, and doing that we find the point of contact. We'll then have a look at it in the plan. Okay, so we'll see something like that on the plan, and then we're going to rotate it around. So the sphere is always going to stay in contact with that cone, but we're going to rotate that around 45 degrees until it meets a 45-degree line going through it here. And when we look at it at 45 degrees, the plan is going to look something like this. Okay, so we've taken that sphere now and we've rotated it around 45 degrees, and it's going to look like that. Okay, so let's start drawing here now on our sheet. Okay, so the first thing I'm going to do is I'm going to measure down about 120 mil from the bottom of my border. Okay, so I'm going to leave myself plenty of space there. And I'm going to draw a line all the way across the page. And I'm going to call that my XY line. Okay, so make sure you label that line. Next thing I'm going to do is draw a construction line about 100 mil in from the left side of my sheet, and draw a construction line perpendicular to that XY line. Let's get that to focus. Okay, that's better. And I'm going to measure up 70 mil. Okay, so the height of this truncated cone is 70. I'm going to measure up that 70. And I'm going to draw a horizontal construction line. Okay, I'm now going to go down and start drawing the plan. So from the plan I'm going to measure down 70 mil to find the center point of this circle here, and from that point I'm going to measure up 35 mil. Okay, so that's the radius of that circle, 35. Okay, and I'm going to draw a circle there. So this is what that truncated cone looks like in the plan. Okay, and because the bucket is shelled out, so if you look at the 3D pictorial, it's actually been shelled out, so all the inside of that bucket has obviously been taken out. We can actually see the bottom of the bucket here as well. Okay, but to find the radius of that, we need to project up the widest part of this circle in the plan. So project that vertically up until it cuts that line that I drew at the start, 70 mil above the XY line. So projecting that up, projecting this one up here as well. Okay, and I actually need to measure down now at 75 degrees. Okay, so I'm going to grab my protractor, line it up here, and I'm going to create an angle of 75 degrees. So start from measuring here. I'm going to measure 10, 20, 30, 40, 50, 60, 75. Okay, so I have projected down now 75 degrees. So I've created a 75 degree angle here. Now, I could go and measure down 75 here as well, but what I'm actually going to do is just flip it around using axial symmetry with the center line of the truncated cone. I'm going to flip it over like this to where it cuts the XY line on this other side. And with a construction line now, let's join in them 2 points up. Okay, so that's just a construction line for now. So if you have forgotten your protractor or you don't have it, this line here is actually 16 mil, but I would encourage you to use a 75 degree angle. But if you don't have the facility to do that, you can just measure 16 mil here. Okay, anyway, so now I have the radius of the smaller circle. I can project that down into the plan. Okay, and that now is what that bucket looks like in plan. So I'm just going to fill in this top line here as a firm line as well. and going to carry on. So the next thing now, and if I read the question here again, there's an important part here. The sphere rests on the horizontal plane. Okay, so that's an important note, point to make note of. So if that sphere rests on the horizontal plane, it means it's sitting on this XY line, which means that the center point is going to be the 30 mil above the XY line, because the radius of that circle is 30 mil. Okay, so if you imagine a sphere rolling along this XY line of radius 30 mil above that XY line is always going to be where the center point is. So the center point is always going to roll 30 mil above that XY line. So what I'm going to do is I'm going to measure up 30 mil. And I know that the center is going to be somewhere along that line. Okay, I can also bisect this angle created by the cone and the XY line. Okay, so to bisect an angle, remember that we're putting this pointy part of the compass, okay, onto the vertex, so the angle created here, and opening my compass and scribing once on the XY line, once on the cone's edge, okay, and then opening my compass just a small bit more and keeping this width now on the compass. I'm scribing out here, and I'm going to scribe out here, from here and from here, so from the 2 points made here initially. And sorry now, the camera keeps going out of focus. Okay, should stay now. Okay, I've bisected this angle now, and where the bisected angle and the line 30 mil above the XY line meet, which is just this point here, is going to be the center point of that circle. Okay, so I'm going to set my compass now to radius 30. And with a construction line, I'm going to draw that circle. Now, what I've essentially found there is the point of contact between the truncated cone and the sphere. Okay, so if I go back to my on shape here again, this is one second now. Okay, so this is a view of the cone and the sphere that we're looking for. Okay, we can't find that until we find the point of contact, and what we have found here now is looking straight in at the point of contact, which is this view here. Okay, so we've found that now. It's a matter of rotating it in to find it like this. Okay, so to do that, I have my center line of the plan, which is down here, and I drop the center point of this sphere down, okay, and I rotate it around. Okay, but how far do I rotate it? Well, that's an important part. I rotate it 45 degrees. So if you have a look here now on our question, we see that the center point lines up with this line here, okay, which has been rotated 45 degrees. So I'm going to get my 45 degree set square, and I can draw a 45 degree firm line through the diameter of the large circle. Okay, and then a construction line continuing out. I'm going to set the sharp point of my compass at the center of the cone in plan, and I'm going to open it out here to where I've dropped down this point. So that is this point here. I'm going to rotate that now around like this. Okay, and where this arc and this 45-degree line meet is going to be the center point of this sphere when I'm looking at it in this view. Okay, so that now has been me rotating that sphere around. Okay, so I can go back up here to the sphere and grab this radius. So I just like to go back up here and take the radius and bring it down here, and I can now draw that sphere in plan. Okay, so it's going to be a firm line all out here, and it's going to be a broken line inside here. Okay, and I'll be going over all of these firm lines at the end as well. Okay, so now to project this point back up to find the location of the sphere in elevation. So that's pretty easy to do. Going to the center point of this circle, which we've now found, and project it up to where it cuts that line 30 mil above the XY line, this line here. And where those two lines meet is the new center point and the center point of that sphere in the elevation. Okay, so again, I'm just going to grab my radius off this circle here and bring it over to the new center point. And I'm going to draw that sphere in elevation. Okay, now that I've drawn that in elevation, I can actually fill in this edge here as well with a firm line. So from here to here and from here to here we're going to have a firm line, and behind the sphere we're going to have a hidden line, like so. Okay, so that's just showed with a dashed line. Okay, so we have our bucket now drawn in elevation and in plan, and this line now going at 45 degrees through the plan with a firm line shows this handle in elevation and in plan. Okay, so we know that when we're looking at our shape, directly in at the front view, like the view that we're shown at the start, we have this to be an elliptical shape. But when we're looking in normal to the point of contact, we see that that's just a semicircle. Okay, so we're actually going to have to draw an ellipse up here. Okay, so what I've done here now is the 2 points where this line at 45 degrees cuts the large circle, which is right here and right here. I've projected 2 of them straight up to the top surface here. Okay, and I've used them to draw this semicircle. Okay, so if you're just watching the pencil here, this point and this point is projected up to find this point and this point, and I've used that to draw a semicircle. And that now is giving me the minor axis. To find the major axis, I'm going to this point here and this point here, and I'm projecting them up. So this point here and this point here, and that will find me the major axis. Now I've already found 3 points on my ellipse. So this point here is going to be a point on my ellipse. Oops, sorry. This point here is going to be a point on my ellipse. This point here is going to be a point on my ellipse, and so is this one. Okay, so I've already found 3 points on that ellipse. The next step for me is to break that up using the 30-60 method. So I'm going to cut that up using 30-60, which is the 30-60 set square. And that's going to divide it into 6 equal sections. Okay, so where them lines cut the major circle, I'm going to be sending them horizontally in towards the center line. And where they cut the minor circle, I'm going to be sending them vertically up. Okay, and that now has found me the 3 points I already know on my ellipse, so 1, 2 and 3, and it's also found me 2 more points here and 2 more points here as well. Okay, so I'm just going to zoom in on that construction for you for just a second. So just to go through that again, where the firm line at 45 degrees cuts the larger circle, I'm going projecting them 2 points up to find this point and this point. Those points are used to find this semicircle, and the widest part of the top of the bucket, I suppose, is found the bigger circle here. I've divided them up using the 30-60 method to divide it into 1, 2, 3, 4, 5, 6 equal sections. Where the division lines cut the major circle, which is the circle on the outside, I've drawn horizontal lines in, okay, towards this center line here. Where the division lines cut the minor circle, so the smaller one, I've drawn lines vertically up. Okay, and where those two lines meet is a point on the ellipse. Okay, and once I found all my points, I can start drawing in my ellipse. Okay, so take your time drawing the ellipse and try to get it as a nice smooth curve. Okay, not bad. Not great either. Okay, so now I have the bucket in elevation and plan. Okay, so that wasn't too bad. That is part A of the question complete. Next one, part B. Okay, draw the development of the conical surface A. So, remember now that this is a cone, only that it's been turned upside down and it's been cut here at the bottom. So if you imagine your cone, okay, and imagine it as a development, and when you roll it out, you're going to get a shape that looks something like this. Okay, so the length of this curved line up here is going to be the same length as the circumference. So whatever your diameter is, you're going to have to do a bit of maths to find the circumference. That's going to be this length of this arc, and then from here you're joining it up to the point, which would be the point at the top of the cone, and that would be joining back up to here. So when you develop a cone, that's the shape that you're going to get. Okay, when you truncate it, you're going to get another arc here, and you're going to forget about all this section down here. that's not going to be there. Okay, so when you're doing a development for a truncated cone, you're going to start with the development for the whole cone, and then you'll get the development for the cut piece, so the piece that you've cut off. Okay, so that's the easiest way to do it. So let's imagine this now first as a full cone. Okay, and I'll do that with a green pen here. So I'm going to continue this edge of the cone all the way down to the center line and do the same over here on this edge. Okay, so that's what that truncated cone would look like if it was a full cone. Okay, next thing I want to do is to grab that height of that cone. Okay, so I've got it here, and unfortunately it doesn't fit onto that XY line, so I'm going to have to go a small bit below that XY line, but that's not the end of the world. Okay, and I'm going to draw an arc like that with a construction line. Okay. And just mark that point. You don't want to lose that point. I'm just going to call that point S, and that refers to this point down here as well, point S. Okay, so I just wanted to draw this out now on Onshape 3. So what I'm essentially doing now is I'm looking down on the top plane, and I want to split this circle into 12 equal sections. And again, I'm going to use that 30-60 method. And in doing that, I'm going to take these measurements, so the measurement in between each of these points, and together they will give me the circumference of this circle. Okay, so to find the circumference, I'm going to take the distance between each of these points on the circle. Okay, so going back to my sheet now, I'm going to break up that circle down here using the 30-60 method. So use nice light lines while doing this. I'm going to split that up into 12 equal sections. Okay, and it's very important now that you index them points. So I'm going to do my indexing here in a red pen, and always start over here with your indexing at this point, and that point is going to be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. And don't forget now to include this distance between 11 and 0. Okay, so that distance has to be included as well. Another thing not to do is we've drawn a 45-degree line down through the plan, and do not draw that or give that an index. So some people might accidentally index that as 2, then have this as 3, and wonder why they have 13 points. Okay, so this shouldn't be included. Okay, so next step now is to take the distance between 0 and 1. Okay, and I can bring that up to anywhere on this curve. Okay, and just remember the point that I started it on. Okay, so the point where you started is going to be point 0, and the point that you moved at is going to be point 1. Okay, and we can keep this distance now and just move along that curve. So we're going to have point 2, 3, all the way up to 11, and then to 0 again. Okay, so if you have to extend that arc, you can do so. Just try to be as accurate as you can with it. Okay, and make sure to index them points. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then 11 back to 0. Okay, all of them points now can be joined back to S. So pencil on S and line them up with 0. Okay, so we've joined all them points back to S. So that's what that development would look like of a cone. Now we know it's not a cone. We know that it's actually a truncated cone. So we're going to have to take another arc over here now again in a second as well. And to do that, all we're doing is opening my compass from the apex of the cone, which is point S, open it up to the XY line, go into S, and draw an arc like that. Okay, and I can go over that arc now with a firm line and go over these edges here. So just the edge here as a firm line, and the edge over here as a firm line as well. Okay, so that would be point B of the section of the question, and C then is the development of the semicircular handle S. Okay, so we know that S is a semicircle as we look at it. So I suppressed it here and unsuppress it, and we know that if we look at it, normal to plane 2, which is at 45 degrees, looking normal to the point of contact, we see that it's a semicircle, even though from the front view it looks like an ellipse. Okay, so again, how are we going to find the length of that? Go back to our drawing, and we're going to take these points here. Do this in a different colour, going to do this in blue. These points here. So from point 1 to 2 to 3 to the top 4, 5, 6, and 7. So we're taking from the major circle, so from the construction line on the outside here. Okay, bad choice of colour. I have a darker blue here, so I can go over him. Okay, so we have our points there, and I'm going to start with a construction line horizontally just below point S, so here, and to get the true length of that bucket handle I can open my compass from 1 to 2 and take that distance and start it down here on this line, so 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6, and 6 to 7. And label them. And then just go over it with a firm line. And you could actually call that now handle S as well. Okay, so the last thing I'm going to do here now is just to go over all my firm lines and to label this question A, or part A, part B, and part C, just so that the examiner knows exactly what he's looking at. Okay, so that is 2019 question 4 section B drawing complete. I hope you found that helpful, and let me know if you have any questions.